Okay, I think we'll get started now. So let's join hands to welcome our speaker today, Professor Srinivas Talluri from the Michigan State University. The research seminar today is on evaluating and monitoring distribution network efficiency with multivariate process control methods. So those who do not know, Professor Talluri is also the co-editor-in-chief of Decision Sciences Journal. And this work that he's presenting today is also inspired from the Dow Chemical Company, and he will be talking about that a bit. So before we go into the topic, I'd like to introduce the speaker. Professor Srinivas Talluri is currently the Hoagland, Metzler Endowed Professor and a Professor of Supply Chain Management at the Michigan State University, East Lansing. His research interests are in the areas of supply risk, buyer-supply relationship, sustainability in supply chain, and performance evaluation. His expertise in methods include both game theory and analytical methods such as stochastic modeling, empirical, and DEA. From what I know, I have read several papers on DEA from Sri, and it is a widely cited articles. He has authored or co-authored more than 100 articles in prominent renowned outlets such as IE Transactions, General Operations Management, Decision Sciences, POM, IGPR, EJOR, IEEE Transactions of Engineering Management, JBL, among others. He's widely cited. His work has got more than 13,000 citations, which speaks a lot of value from the impact perspective. And he's also the fellow of Decision Sciences Institute and a member of the Decision Sciences Institute and the POM Society. So without much delay, I would give the floor rather than Zoom to Sri. So Sri, the floor is yours, and others, please put your questions in the chat window. I will be moderating that. And we'll also hopefully have some time towards the end to have some conversation. Yeah, over to you, Sri.
Thank you so much, Devajit. It's really fantastic to be able to join you folks with this talk. And of course, if the pandemic were to soften, we'll see a lot more face-to-face, interactions. And I certainly hope that we'll be able to do that at some point in time. Today's talk, so let me just try to go to the presentation mode, is kind of based on some of the work that we're doing with companies here in Lansing area. And it kind of dovetails well with some of the changes that we are making to the Decision Sciences Journal, in that we are trying to focus on anchoring the business problems in practice, because as Devajit just mentioned, there's a lot of work that I've done in game theory, very stylized modeling and so on, and I continue to do that. But also, the question always comes up if you're in the business school, what is it that you're doing for practicing managers, and how relevant is the research that we are doing, right? I mean, given that we are more of a professional school that has good links with industry. So, I mean, Michigan State has always had a fantastic link with companies, with the automotive industry being close to us here, not only the big three, but all the suppliers and so on. So what happened here is that in 2015, Michigan State started this AHMEDABAD Institute, which is funded by Dow Chemical and also some of the Midland-based companies that were a part of it. Excuse me, I think I just... And quite a few Midland-based companies also gave us some support. The focus is basically on coming up with collaborative solutions to solve a variety of industry problems. So, most of the projects under this charter are basically helping companies, So from that aspect, the work that we've done here is slightly different from some of the traditional work that we normally publish in journals. And I think given that there are some MBA students here, they probably would be able to appreciate, some of this type of work. So the projects are quite interdisciplinary in nature. So normally when the call comes out from Dow or some of these other companies, we form a team. It's got faculty from College of Engineering, Business, Criminal Justice, Ag. So that way it kind of provided me with really an opportunity to interact with folks that I normally don't interact with, because you're normally in your silo, you're doing your work, you're working with your doctoral students and so on. But this gives us an opportunity to interact with colleagues from other schools within the university. So with that, if you put that in context, okay, so basically Dow came to us with this problem, in terms of looking at their distribution network. And I'm actually happy to mention that they're currently using this model. Although the data that we had and the analysis that we have done, that's based on some of the past data. But I mean, that's due to confidentiality issues. It was difficult for them to provide us with some more recent data. But as you will see, it's the data itself is not a huge factor in these models that we are trying to apply here. It's more in terms of coming up with a methodology that would assist the companies to be able to monitor this distribution network efficiency or any other kind of process improvement techniques or whatever Dow actually implements in terms of improving their network. How are you able to kind of capture that in a more holistic sense? So the current methods that Dow has been utilizing for network redesign type of issues is mostly cost optimization. So they just go through like a transportation or transshipment type of cost model that basically tells us, how do we, source different customer locations based on, a variety of, warehouses and plants that we have within the network. But what Dow wanted to do is a little bit more than that. I mean, cost optimization is fine, but how do we kind of incorporate factors above and beyond cost and, kind of evaluate, performance in a more, holistic sense, and some sort of a monitoring tool that would tell them based on these multiple factors, okay, how efficient their network is and whether they have to undertake any sort of, interventions, if the network, performance is not up to the mark. So that's what this methodology basically does. It kind of takes multiple factors into account, factors above and beyond cost, and uses some multi-factor methods to evaluate the performance of this network. So I think I've got some issue with my slides here. Not moving to the. Okay, let me just stop share for just a minute. Sometimes it does that with my. All right, I might have to manually do this. So
that's fine. Yeah.
So the contributions of this specific paper, again, how do we look at the efficacy of network improvements that have been undertaken by Dow? That can be in terms of network optimization or any other interventions that they may have in place. And the second thing that we also looked at is impact of some risky events on network performance. So one is more of a positive type of a systemic type of an intervention that Dow had to go through. And the second one, which is mainly a disruption. So it's almost like a natural kind of an experiment, what kind of a negative impact that has on network performance. So, and then we are basically looking at new and innovative approaches to monitor the network on a real-time basis and provide feedback to Dow in terms of what kind of adjustments that they have to make or what specific parts of the network are vulnerable and how they have to actually improve the process. So that's where we are focusing on utilizing these multi-factor methods and control charts to be able to do that. So some sort of a dashboard that provides them with kind of monitoring and flagging the process if it is kind of going out of control. So, I mean, there's a lot of work within the broad domain of multi-factor performance modeling. People have talked about considering multiple factors within this context. If you look at some of the traditional work that's been done by Kaplan and Norton, which is the balanced scorecard method, that basically, focuses on looking at, alignment with respect to different processes and, perspectives that would lead to improved performance. And others have pointed out that you need to consider factors that are multidimensional in nature. And so you cannot use a single kind of an indicator to evaluate the performance. But more importantly, I think when you look at these multiple factors, there can be trade-offs, right? So if you look at some of the manufacturing literature or literature within the project management space that looks at factors like cost, quality, time, and so on, where, like, for example, if you put more emphasis on responsiveness, then that's going to come at a cost. So how do you kind of take those interrelationships among these factors and incorporate that into the decision model? Because clearly, right, as you try to increase a factor, let's say the performance with respect to some of the other factors may be moving in the opposite direction. Okay. So again, I'm not going to go through all the literature review here, but if you look at the performance evaluation space, score model comes into play a lot, especially when you talk to practitioners. How do you kind of look at the performance of the supply chain almost from cradle to grave, by looking at sourcing, manufacturing, distribution. So you've got multiple metrics across these different, echelons within the supply chain. And you're trying to capture data across these different metrics, and you're trying to benchmark it with some sort of an industry standard so that you're able to understand what the gaps are and how to kind of, improve the performance. And likewise, other techniques like AHP, ANP, which are multi-criteria methods that have been extensively utilized in capturing multiple factors and aggregating that into a single meaningful index. But again, these types of methods are more qualitative in nature because you're using a scale of 1 to 9 or so to come up with these pairwise comparisons that we do. And it's got issues with respect to rank reversal and so on. And there are other qualitative methods like case-based reasoning, where a new case is compared against a database of existing cases. And based on that, there are lessons learned and so on. So the mix of qualitative as well as quantitative type of models that look at these different or look at performance in a multidimensional scale. The reason why we are considering DEA-based methods here, is because of the ability of the technique to be non-parametric in nature. Because normally, right, when you're dealing with this type of data, and I'll show you some of the data characteristics, there are a lot of issues with respect to normality, equal variance or independence and so on. So when you use parametric techniques, it's difficult to kind of satisfy the assumptions of the data. So the advantage of DEA-based methods is it's based on LP type of simplistic, LP type of a model. So it is non-parametric in nature, which kind of dovetails well with the assumptions that we're dealing with in this type of data. And again, DEA-based models have been extensively used. So I'll just give you a brief introduction to the kind of models that we're using in terms of taking those multiple factors and aggregating that into a single meaningful index so that we're able to monitor, right? And how do you actually capture those interrelationships across these different factors? So this is basically the base model, which we call as a CCR model, after Chance, Cooper, and Rhodes, the inventors of the model. So it basically works under the assumption of constant returns to scale. Okay? So basically, if you look at the little graphic that I have on the slide here, as inputs increase, we are assuming that outputs are going to proportionally, increase. So on the left-hand side here, I've got the fractional programming model. So let's say you've got a homogeneous set of decision-making units. That could be suppliers or plants or distribution centers, right? You're looking at the performance of this homogeneous set of decision-making units with respect to multiple input and output factors. And the efficiency is basically the ratio of weighted sum of outputs to weighted sum of inputs. So that's what you're trying to maximize for each unit in the set, subject to the constraints that the output to input ratios for all the units in the set is less than or equal to 1. So some sort of a normalization so that you're able to do an apples to apples comparison. Now, the interesting part with this model is that you can take this fractional programming model and you can convert that into a simple LP that can be solved once for each decision-making unit. That would give you a score of between 0 and 1, where if you get a score of 1, then the unit is considered to be efficient, and closer to 0, right? The efficiency is basically lower, and you are an inefficient decision-making unit. Now, that's the base model, and this is the primal version of the model. And in LP, there is always a primal dual relationship that we look at. So this is the dual version of the model. Again, I'm not going to get into all the details with respect to the model, but the reason why I'm showing you the dual model is because it's easier for me to kind of introduce the variable returns to scale model. Basically, you take the primal model of the DEA, which is the Chance, Cooper, and Rhodes model, and you append this new constraint, the convexity constraint, that is sigma of lambdas equals to 1, and that gives you the dual model corresponding to the BCC, which works under variable returns to scale. So, in a nutshell, what we're saying is that as inputs increase, there is kind of a stage where the outputs are going to increase at an increasing rate. There is a stage where the outputs would increase at a constant rate, and there's a stage where the outputs actually increase by decreasing rate. So it's basically non-constant returns to scale. And the importance of this model is most of the production models kind of fit this type of a context, right? Where as you put more inputs into something, the outputs may increase, but above and beyond a certain point, the output may increase at a decreasing rate. So, again, the idea is to take these multiple factors that Dow is able to provide us with respect to the network, and aggregate that into an index, okay, and then be able to monitor that index over time to see how the network is performed, right? So to be able to monitor it, we need some sort of a statistical procedure to do that. And for some of you that have taken MBA classes in quality control and so on, you've been probably exposed to some basic control charting methods like Schwartz or possibly even Q-sum charts. But the key issue there is, again, in terms of independence and normality of data. So what we are trying to do is to utilize multivariate charts that are able to monitor multiple metrics simultaneously, but relax some of these assumptions in terms of normality, independence of data, right? Because sometimes the data can be serially correlated if you're looking at time series data. So how do you kind of get away from some of these baseline assumptions? So the non-parametric chart that we're using to monitor the process is very recent. It's kind of a 2020 piece on this particular technique. What it basically does is, okay, if you're monitoring, let's say, multiple 2 or 3 different variables. So for each of these variables that are being monitored, that value is compared with the median of the variable. And a binary indicator is basically assigned. So if the value is greater than the median, you get a score of 1. If the value is less than the median, then you get a score of 0. Okay. Now, when the data is in control, what you would expect is that the variable values are equally likely to be above and below the median. That's what we say, right? You don't want any systematic effects. You just want a random scattering of points. But if you see consistently the data being either above or below, right, then you have to flag the process. So this technique basically flags it by taking the differences between the 0, 1, indicators that I talked about with the corresponding expected value. And we actually look at the square distance. And that's why this particular chart, does not have a lower control limit because you're squaring. You only have the upper control limit. So those are the two methods that we are using. But just so that you kind of follow what we're doing here, we have multiple metrics, and we are utilizing DEA to aggregate the performance of these different metrics into a single meaningful index. And then we are trying to see if you can monitor it using a QSUM chart individually or jointly with the DEA scores. What kind of impact does that have, and how efficient is it to kind of capture the shifts in the process. So basically the methodological contribution here is to improve the efficacy of the QSUM chart. And that's what you will see, that in some cases, right, that what we are proposing has a better way of capturing these minor shifts in the data. So now, just going to the case company details, I already talked about the company being Dow, and we basically identified a business unit with the assistance of this case company research team, and we had to do multiple online visits to capture the data. This is the other part, right? If you're working with a company, it's not easy to get access to the data, and they have all kinds of confidentiality issues. That's why, as you will see, some of the data that they released for us is a little bit dated. But since we're trying to kind of demonstrate the efficacy of a tool, it really doesn't matter, how old the data is, if it's able to do whatever, if the model is able to do whatever that we are proposing that it can do. So we had a doctoral student, that was a part of this process, and the amount of data gathering efforts was quite significant in terms of capturing the information from multiple databases and so on. So the distribution network itself has 6 manufacturing plants, 6 warehouses, 869 customers, and 699 products. As you know, Dow's products, range from performance plastics to pesticides to water treatment systems and so on, right? So we had to kind of select one piece of that network because it's kind of hard for us to be able to span across, all the different products that Dow is focusing on. So again, this is a family of products that we basically looked at. And here is the distribution network. I mean, I cannot get into a lot of details, but I can quickly show you that shipments from plants to, the different warehouses. So we've got about 5 warehouses in the US and 1 warehouse in Canada. And then it goes to 4 regional locations where it is shipped to. And as you can see, they're all over the world. You've got Asia, Europe, Latin America, North America, and so on. And then, of course, it goes to the customer locations. Okay. Now, so Dow's network optimization model is to minimize the transportation cost. And the decision was basically to reassign customers to different warehouses. And the optimization, right, one of the kind of things that they want to look at is how efficient the optimization is. Okay. And again, I do understand that the data is a little bit dated, but again, for the method that we are using here, it's the efficacy with which it can capture those changes, right? So the network optimization model was actually implemented in July of 2013. Okay. And the data period that they gave us was from October 2011 to April 2014, the daily data. And we took some time to set up the QSUM chart, which was because you have to first create the chart to be able to monitor it in future time periods. So we set up the chart from October 2011 to December 2012, and the monitoring period was from January 2013 to April 2014. So two major events, and what is the efficacy with which we are able to capture those? The first one is the distribution network optimization that I talked about that was implemented during May and July of 2013. It is a systemic change, right? So it is an intervention. And what is the efficacy of this? So before optimization, the data that we looked at was January through July 2013. After optimization, August to December 2013. And the second thing is these winter storms that we had to deal with, January through April 2014. It's a transient change. So before storms, which was August to December 2013, and during and after storms, January through April 2014. So the idea is to check and see, based on these multiple factors, did the performance actually go up when you compared before optimization to after opt? Likewise, did the performance go down when we went from before storms to after storms? So the factors that we considered in discussion with managers at Dow for the DEA model, the inputs are transportation cost, which is in dollars per pound, and number of operational problems that includes product damage, incorrect shipments, whatnot, and outputs, mainly the customer service level, which is on-time delivery rate. Now, this is slightly different from the way you characterize inputs and outputs in a traditional DEA sense, because in a traditional DEA sense, inputs are any resources that are used, and outputs range from actual products produced to a number of performance and activity measures. But here we are considering whatever low is better as inputs and whatever high is better as outputs, because the idea is to maximize that score, right? So if you have low transportation cost and low operational problems and high customer service level, then clearly the network in that specific period is performing well, right? So, so the definition is not in a traditional sense, but it still captures, the essence of, the network, performance. When inputs are low and outputs are high, that means the network is actually, performing well, right? So going back to the data characteristics of these three variables, first we checked for the normality using Shapiro, Wilks, and Kolmogorov and Smirnov tests, and we had rejected the normality for all three of these factors. And then all three pairwise correlations were statistically significant as well. And then we also looked at some, autocorrelation tests, whether data is, correlated over time, and all but one, which is the transportation cost, were auto-correlated. So clearly the traditional control charts are not suitable for monitoring, right? This type of data, because the standard assumptions are not being met. So that's why we are resorting to this non-parametric QSUM chart. And there were no seasonality issues. We checked for that. And finally, the process was not stationary. Okay, so we had to reject that null hypothesis as well. So clearly, right, we needed a tool because of the issues with the data, a non-parametric tool. And so that kind of dovetails well with the DEA model, because the DEA model is non-parametric in nature, and the control chart that we're using is also non-parametric in nature. So first thing that we wanted to do was to kind of do a static analysis. And if you look at the efficiency scores that are generated by DEA, that is, they're not going to be normally distributed. So instead of using a traditional t-test, we are using the Mann-Whitney test here. And the general hypothesis is that no difference in efficiency scores between two segments of data. And the alternative hypothesis is that the efficiency scores of one segment is higher or lower than the efficiency score of the other segment. So if it's basically the network optimization model, we are expecting higher, right? And if you are using the winter storm, kind of data, then we're expecting that after winter storm, the efficiency scores are going to be lower. So we ran them, separately. So what we did was we solved DEA for the entire period. Okay, so from 2011 to 2014, we had 642 data points, and then we tested this using the Mann-Whitney test, and clearly, not just with respect to cost, but with factors above and beyond cost, it demonstrates that for both the BCC model, which is the variable returns to scale model, and also the CCR model, constant returns to scale, both scores went up and they're statistically significant. So what we're saying is that the after optimization scores have increased by 11% in BCC case and 10% in the CCR case. So Dow was pretty happy about that, given that we passed on this information to them saying that, hey, although you have applied your optimization model to reduce costs, it also had a positive influence on some of these other factors, like your customer service level, right? And also the issues with respect to the quality issues and the defects, right? The three factors that we actually looked at. So that's a static type of analysis, just to demonstrate that this type of an intervention in the form of optimization actually worked positively for Dow. And this is the tool that they're using now for any intervention that they have in the network. They redesign the network. Then they can actually use this tool to check whether the new redesign, or if they allocate certain resources to different parts of the network, right? Is that kind of impacting the performance in a holistic sense? Then we kind of thought that let's do some real-time monitoring. Of course, it's like real-time monitoring from the standpoint of mimicking it, where we thought, let's compare the Q-sum chart with three variables with the Q-sum chart with three variables plus DA. Okay, what is the rationale for doing this? If you look at the traditional Q-sum chart, while you consider the three variables, the interrelationships and trade-offs among these variables, that battle, right? Where you try to increase, cost, then you expect to see better in terms of, let's say, the customer service level, right? If you're using an expedited transportation process, then the cost per pound is going to increase, but you're able to meet the customer demand in a more, efficient manner. Okay. So that trade-offs, right, between these factors cannot be captured through the traditional Q-sum chart. So we said, let's add DEA to the three variables that we already have and see if it is a better tool in being able to capture, right, these shifts that you can experience either through network optimization, right, or through the winter storm that we had. So the goal is to basically provide a signal at a time close to the event. So once you implement the network optimization, how long is it taking for your method, okay, to capture that shift and say that, yes, the shift is positive, okay? Or to capture the shift and say, yes, the shift is negative, right? How efficiently are we able to do this? Okay. So I've got some interesting results for you here. First, when we ran the Q-sum chart without the DA scores, okay, using these three variables that we have, the first signal showed up on 10/16/2013, which lasted only for 1 day, and the accumulation of the charting statistic started on 10/7. So if you look at the graph here, I've got some circles that are plotted there. So this is before network optimization to after network, right? After network optimization, is the performance getting better, okay, right? So the Q-sum chart was not really efficient in capturing that. So although it is outside the upper control limit, it actually means that the performance is better, right? Because we are showing that the process, something is happening in the process, and the process mean is actually shifted when you went from before to after. So since optimization has a positive effect, the point goes outside the limit, but we would like to see a more consistent kind of a pattern rather than just a blimp outside, right? Because if you look at traditional control charts, you've got a point outside the control limit. It could be totally a random occurrence, right? Even the process in control, every so many time periods, right? A point will fall outside the control limits because of the probability of a type 1 error. Right? So this was okay, but it really could not capture the shift. And moreover, okay, when we ran these three individual Q-sum charts, right? So running Q-sum charts separately, right? For the three variables, not a joint chart, nothing is shown really. So it's not able to actually capture the efficacy with which this network optimization has worked. So what we did was, right, we utilized the DEA as the fourth variable. Again, the rationale for that is because of the trade-offs that are not being captured by the traditional Q-sum chart. And we did some, windows analysis here. And as you can see from this data, right, I'll just go to the chart because it's a little bit easier for me to show you. If you juxtapose this chart, okay, with the one that I just showed you with the Q-sum chart, right, where the signal was very weak, right, and not able to capture the effectiveness of network optimization with respect to both BCC as well as the CCR model, more BCC than CCR, of course, right, clearly shows the impact of network optimization. So before is to the left here, where you're below the control limit. After is to the right, and there are quite a few points, and there's a systematic effect that clearly network optimization has improved Dow's process. So again, it's a diagnostic tool, but how do you when you have an intervention in place, right? How do you best capture the efficacy of this? And that's what we are basically demonstrating here with this tool. Because sometimes the shifts in quality control, the shifts in the process mean are very, very small. So what is the ability with which you can capture those small shifts? So clearly, this is very good news and for Dow, and they are quite happy to see that the trade-offs between different factors that DEA captures is actually helping them better understand the effectiveness of the tool that they have implemented. So then we actually did the same thing for winter storms, right? So now we want to see the opposite type of an effect. And during January 2014, I'm sure you've read in the news that we had severe disruptions, and that included production, construction, shipment, and there was a significant drop in GDP because of the winter storms that we experienced. So that's the other thing that we wanted to check, because it's kind of a natural experiment from that standpoint. This already happened. How efficiently is our tool able to capture this shift? So this is where I think it is interesting. The first thing that we did was, again, we are basically duplicating the analysis that we did before, is to solve the DA for the entire period and then check and see whether actually the scores have gone down when you compare before winter storms to during and after storms. And clearly the BCC scores went down by 14% and the CCR scores went down by 21%. That's basically the static analysis. Now we did the same thing. The three variables, okay, running them jointly, plus the three variables plus the DEA, which is the second model. And the goal is to provide a signal at a time close to the event, that is the winter storms, right, from January through April 2014. So now, again, I'm just going to skip this and show you the chart. This was a lot better. Okay, so the QCHM chart actually provided us with very consistent signals. Of course, the first signal came up, that's you see the first circle, and then again, there was not a signal until like January 2014, right? But that from that point onwards, right, until almost April 15th, 2014, clearly it was showing you that something is happening to your process, and that something, although it's outside the control limit, right? Basically, it is telling you that, the efficiency scores as a result, right, of your, of the winter storm, the performance of the system is actually going down. So so the QCHM chart did a lot better with winter storms in capturing that shift, as opposed to the shift that is associated with the optimization. Then we ran the DA plus the three variables to see what kind of impact does this have, and slightly better than the QSUM chart, but so it was, as you can see, right, it is very consistent for both models, showing that something systematic is happening, which means the efficiency is going down. So slightly better than the QSUM chart, but for this scenario, both QSUM chart and DEA were equally efficient in capturing the shift. And then we looked at, of course, I'll just skip this slide because that's redundant. So basically, right, we presented a combination of DEA-based approach and non-parametric tools for monitoring the distribution network in supply chains. And we tested the impact of specific interventions within this context and mimicked this real-time process monitoring. So in conclusion, basically the punchline is this. If it's a major shift, like a winter storm, right, that is a major disruption, then both the QSUM chart and QSUM plus DEA are able to capture the shift in an efficient manner. So when the process is in control, let's say, suddenly the mean goes up, okay, it's the magnitude of that shift. If the magnitude of the shift is high, then both these methods are able to capture it. But when the magnitude of shift is small, right, see, that's when the issue is, because something like network optimization, there are going to be improvements, but the improvements are not going to be as drastic, right, as some sort of a huge intervention like the winter storms that we looked at, where the efficiency is going to be a lot lower because of all the different types of negative impact that the supply chain actually goes through. So what we're proposing is that for minor shifts, QSUM plus DEA seems to outperform the traditional QSUM chart. So that's basically a methodological contribution. And of course, the practical contribution is to providing company with a specific tool so that they're able to test the effectiveness of some of the quality-based improvements or process-based improvements that they're able to undertake. Now, you may ask the question, right? This is going to be more like a diagnostic tool, but what are you prescribing, right? What can you propose to Dow that basically says, hey, this is where the issue is, and this is what you need to be doing, right? So what we did was, for the winter storm case, okay, we wanted to kind of dig deep into this. Okay? So I'll show you some part of the, the other analysis that we've done to look at which parts of the network are actually vulnerable. Okay? So then we compared the efficiencies of the individual warehouses to the entire network. Okay? Mind you, we don't have access to this plant data here. So for us, the network is basically shipments from warehouses to the regional distribution centers to the customer locations. So what we have done is to compare the overall network efficiency to each of the individual warehouses to see where are the vulnerabilities within the network here. So this is, of course, we took the data at a much higher level. We aggregated and got the monthly data. And then we looked at the correlations between the efficiency of the network and efficiencies of the individual warehouses over time. Okay. And based on that, we ran a clustering approach which can help us with some possible improvement strategies. And this is the dendrogram that we got for the clusters that are based on the CCR scores. So as you can see, right, if there are like broadly, there are like 3 different, clusters here. And so we've got a cluster in pink, we've got a cluster in brown and a cluster in blue, which is just the warehouse C. And as you can see on the y-axis, the similarity is basically decreasing and dissimilarity is increasing as you go from bottom to top. Okay. So we focused on the cluster in the middle. And as you can see, right next to overall, which is the network efficiency in this context, warehouse F sits right next to that, which means those two are really the closest in terms of the correlations and the maximum impact that you're having on the warehouse. That is the warehouse F seems to be having the maximum impact on the overall efficiency of the network. And then we went into we did some multiple comparisons here and looked at what is going on with this warehouse F during that period. So transportation costs were high and the customer service levels were on the lower side. And all those differences are, statistically significant. So there are 2 parts to this, right? First, we are using the methodology as a diagnostic tool, and we know there is some problem, but now actually let's get into the problem and see what exactly we can do. So this provided Dow with some input into, where do you have to actually allocate some resources to be able to improve the process so that, right, that will have a, overall positive impact on the network. And we've done some other models, on this. Basically, there are some unrestricted weight flexibility issues and so on, but those are all, methodological in nature. So, basically I can stop here and open it up for any questions that you may have. And before I stop, I just want to kind of say that this kind of work is a little bit different from some of the other work that I do. And again, I've done a lot of stylized modeling and so on, but the practical impact, especially within the charter of this institute here. How can we take some of the scientific models and that we are working on and apply to a business problem, okay, and demonstrate what kind of practical implications can be derived from that process and how companies can actually use the kind of work that we're doing in academia. So that kind of bridges that gap between theory and practice, and this paper basically fits into that context. So thank you for the time, and we can open it up for any questions that you may have.
Thank you, Shri, for this wonderful talk and its relevance. So if any participant have any questions, please, you can either unmute and speak, or you can even write it in the chat and I can moderate. And while you're waiting for a question, I had one, which is, I understand there are 2 parts of the story. One is you first optimize the network, right? And based on the optimization of the network, then you see some performance measures, and then you see what's the inputs and outputs, and you kind of benchmark. So when you draw the post and the pre, usually in control charts, we also have the center line. where we keep on benchmarking the center line, right? So here, do you think we need to shift the center line too, or it is not required because it was you wanted to really show the difference? Or
Right. So basically, in this type of a chart, which is the Q-sum chart, there is no center line really. There is only the upper control limit, because what this chart is basically trying to do is it's not telling you whether the process is improving or whether the process is degrading. All it tells you is that based on the data that you're giving me, something is happening in the process. So if it is outside the upper control limit, it could be a positive thing, or it could also be a negative thing. But we are able to capture that through the DEA model. I mean, we know that if it's a winter storm, right, and then points are outside the limits. So basically the chart is telling that something is happening here, which is systematic in nature, but it doesn't tell you whether it's a positive effect or a negative kind of an effect. But the DEA scores are basically telling us. So that's why we needed to run that first to establish that, yes, if it's a network optimization model, then the DEA scores have actually improved. If it is a winter storm, then the DEA scores have actually gone down. But now the shift is being shown through just outside the limit, because that's how it basically captures it. And the reason for that is because also the fact that since we are squaring the difference between the binary and the median value, right? It'll never show you, so that's why you don't have a lower control limit. So that's why you won't be able to differentiate in this context, whether things are working well or things are not, for both positive and negative effects. It has a very similar type of a pattern. So the center line really in this context doesn't provide us with a lot of information because of that reason.
Sure. And just a follow-up question maybe. So do we need DA, or we can just do the optimization and see the difference in the cost heads, profit heads? So why do we need this tool here? Yeah.
Right. Because of the trade-offs, right? Because you can, if you kind of just look at the differences between, let's say, cost and differences with respect to cycle service level, the customer service level, or differences with respect to the quality, right?
Yeah.
So you can have statistical differences there, okay? But what does that mean at a aggregate level?
Got you.
Is that really because that's where the trade-offs are, right? I mean, the process may be better with respect to cost in certain time periods. It may be better with respect to the customer service levels. So how do you kind of rationalize those differences in a manner that is consistent across the time horizon?
Oh, great. I don't see any more questions right now. Unless Deepti, you have a question, please go ahead.
Yeah, I think it's very similar to what you were asking. So if the company were just observing the output levels, so here it is a customer service level that is being considered as output, right? If the company was just observing that, would they have missed out on these two signals? So considering that these two impacts are very, very powerful and very large, so just by observing the output service level, wouldn't they have kind of understood that their process has deteriorated or not? So that's one question I had. Yeah. And the second question is that, so how much of a shift and for how long time period it should be there for this model to detect it? So maybe like if the same shift happens, during a larger period, maybe like would it miss it, or it has to be like in a very short period? How does it work?
Yeah, so it's kind of hard to. I'll take your second question first. It's kind of hard to say, as to how many data points do you need to capture the shift, because I do agree that we need more data to be able to check. And Dow said that they would kind of run the model and some of these other interventions that they're having and test the effectiveness of the tool. But I think what we are basically trying to say is that if the shift is, if the intervention is of a very high magnitude, okay, it could be a positive or it could be a negative one, then clearly, right, both methods are able to capture it with high degree of confidence. But if the shift is small, then it becomes a little bit difficult for the traditional Q-sum chart to capture it, because the interrelationships among different variables and the trade-offs that is only being included through this DEA model. So again, to answer your question about how long is it going to take, my guess is going to be as good as yours, because I just don't know. We just need a little bit more data to see, or maybe through simulations to check and see, how efficient it is to capture it. But also, I would say that if you add more number of variables, okay, then it may become a little bit more less sensitive, because the weights that are kind of attached to different parts of the model, could kind of be not as significant. So one thing is that if you are able to select a parsimonious set of factors that are truly going to have a huge impact on the performance of the network, then I think the model, the DEA model, is going to be a lot more efficient in capturing the shifts, as opposed to using a large number of variables where the efficacy may not be as good. So that's the answer to the second question. The answer to the first question, right? If you're just purely based on output, okay, and not really looking at what are the resources that are going into the process, that's not a very good way of, managing your system, right? So you could be very, very effective, but you're not very efficient, because what is under our control is to be able to focus on the input factors to make the process efficient. So, I mean, clearly, right, if you just focus on the output factors, you're going to be a lot more effective, but at what cost, okay, are you kind of, getting to that level? So that's why I think you would need a more comprehensive kind of a model to capture both the inputs and the outputs. Does it make sense? Or does it answer your question?
I understand that, but my question was because you actually consider only two particular interventions, right? Both were significant. In that case, yes, it might be easy to see that from the output levels as well. So are there some other, interventions which is not very significant, but it was still able to be captured in this kind of a model?
Yeah, I mean, so again, so that depends on the type of, intervention, and it's kind of hard to say, whether just using the outputs would be able to capture it, or a combination of inputs, outputs, but the main idea is this: it's not so much inputs and outputs, okay? I don't think you should look at it that way, because I can characterize all three of them as possible, outputs of the model. Right? Because I want low cost. I want low, defect rates, or, quality problems and so on. Okay. And I want high, customer service levels. Okay. The only reason why we kind of looked at it as input output is because, as I said before in my talk, maybe that was, it's kind of missed or something like that. The input factors are purely metrics where low is better, and the output factors are metrics where high is better. So inputs are not really like resources in this context, and so they're all factors that Dow wants to capture and kind of understand how they impact the overall performance of the network, but they're classified as inputs and outputs just for running the DEA model. So I hope that clarifies.
Thank you so much.
Yeah, of course.
Shri, there are a few questions, but they want to ask if you have a working paper, they can study more. So if you have,
I can send a copy of the paper,
yes,
and they'll be. Yeah. sure.
Yes, that'd be great. And Shri, last thing is that, there are a lot of doctor students here. Do you want to give a quick peek about the Decision Sciences Journal while they're?
Yeah, sure. So let me do this. Let me see if I can. I have a short presentation, so maybe that would help out.
If it's not too much of a trouble.
Oh, no, it's not a problem at all. I'm just trying to capture the, let's see. So are you able to see my screen or no?
No.
Okay, hang on for just a moment. How about now?
Yes. Yeah.
So this is a talk that I gave in China, but I think it works out here. Maybe I can quickly go through this. Again, I'm not going to run the presentation mode because there are some issues here. So let's see. All right, so Xenophon Kufteris from Texas A&M University and myself are co-editing this journal. And just to give you a little bit of history, DSJ completed 50 years, okay, and we basically publish papers that are anchored in business problems, and that's why I thought that it'll be interesting to present a paper today, which is kind of of that ilk. So the focus is on supply chain and information systems. Having said that, I'll talk a little bit about our interface departments with accounting, finance, and so on. So we do look at papers that kind of look at those interface issues with other functional areas of business. Decision making, the decision making aspect that is really important for us. And as I said, we are methodology blind. We take empirical, math modeling, experimental case studies, simulations. We are fine with any of those as long as the research question is relevant and meets the focus of the journal. So what makes the journal different? So the new policy that we instituted now is that research has to be motivated with direct interactions with relevant constituents. Okay. So you can certainly motivate the problem through lit review and references to popular press, but that's not going to be in itself enough to be able to motivate the work. So we need these direct interactions. And again, the main reason for this is not so much the empirical work that we've been getting, but a lot of modeling work has been extremely stylized. Especially the papers that we received in game theory and so on, where there is a buyer, interacting with two suppliers, and you've got, some competition between the suppliers, and then you come up with a game theory type of a framework to look at that type of model. So, but our question more is, who is this buyer? Who are these suppliers? What are the current contractual, mechanisms that actually govern this relationship? Right? What are the existing ways in which the buyer is doing business with these suppliers, right? And how is your model, able to kind of take some of those interactions and kind of help you in the development of the model, and also in terms of justifying some of the assumptions and so on, right? So those are the things that we are really asking for. So any paper that does not follow that format is going to be unfortunately, desk rejected and send it back to the authors for them to fix this issue. And the second thing, while the focus is on operations and IS, we do look at papers that are at the interface, as I said, of other functional areas of business like accounting, marketing, finance, etc. But if it's a purely accounting paper, if it's a purely marketing paper, purely a finance paper, then it's not going to fit the journal. So clearly that is something that goes back to the author saying that there's no fit, right? And the structure of the journal, it's a large production, not from the standpoint of volume. Volume is very small for us. We only pay, publish about 36 papers a year, and we have 6 issues, so 6 times 6, right? So structure, we've got 16 departments. We have 28 DEs, and I listed some of the new departments that we added. And we've got about 130 AEs and about 170 editorial review board members. So now the ERB members, that's something that we instituted, last year when Zen and I took over, because our quality was all over the place. We had about 3,000 reviewers in our database. Okay. And every time an author submits a paper, they have the opportunity to nominate reviewers. And what is happening is that all those reviewers were actually going into the reviewer database. Okay. So Zen and I, what we did was that we sat through the entire list. Okay. And this was really a monumental task. Of the 3,000 reviewers that we had, looked at the quality, timeliness, and rigor. And then we condensed that to 170, which was tremendous amount of work. Okay. So, and these 170 ERB members, they have published in top tier journals. Like, we look at whether they have any publications, JOM, POMJ, DSJ, so on. And a lot of us, we actually personally know them, because, there's this, the field of operations management, it's quite small from that angle, right? And we meet a lot of these people at the conferences. So if there is a delayed review, I can certainly call any of these people and say, hey, can you please get this processed as quickly as possible, right? And they're on a 3-year contract. And for us, they have to do about 5 to 6 reviews a year. So that's what we have done. And this is really helping us, in terms of cutting down our lead times and improving the quality and the timeliness, as I said. Some of the new DEs that we added, if you look at the schools, Dilip Shahzad from Purdue and Elliot Bendalee, Sriram from Michigan State, and Anant Mishra, and so on, Johnny, and So as you can see in the list of schools, we have some very good schools, and these are all very well-known scholars that have extensively published in the domain of operations and supply chain management. So, but of course, we need to kind of increase our international presence. So if you look at, especially in the DE board, Luke is there, and then we've got Stefan Wagner. But again, from India, China, and some of the other places, we have really not been able to have a lot of representation. We are certainly working on that. But our AE board, certainly we've got many scholars from India and many scholars from China that are a part of it. So in terms of the review process, all submissions are basically reviewed by either me or Zen. And if it does not fit the scope of the journal, so like, for example, if it is purely an accounting paper, it does not fit. So then it's going to get desk rejected. And we also look at the contribution and practical relevance of the paper. And that all important link to practice, whether the authors have done a good job in being able to motivate the problem with those direct interactions with relevant constituents. So if they do all of that, then the paper passes through a DE. And then the DE is going to select an AE, and at each of these levels, right, there is, they have the, authority to desk reject the paper as well if they think that the contribution is not there. Because sometimes, if the paper is submitted to, let's say, retail operations, I don't know much about the specific domain and, what kind of work has been done, or, whether it is the paper that is submitted is making a, contribution in that space. So I usually let the Ds kind of handle that because they are the functional experts. And then we assign the paper to, the AE basically assigns the paper to 2 or 3 reviewers, and we only select reviewers from our ERB. Okay. So we specifically told the AEs now and the DEs that we cannot have the paper be reviewed by somebody who is not a part of our editorial review board. And that really definitely helped us with those 3 metrics that I have listed there: rigor, consistency, and timeliness. So the average turnaround time is 36 days, but that includes desk rejects. Okay, so if you take out the desk rejects, then of course that number is going to go up. So that's for the original submission, and the second one is for the revision. So how are we doing as a journal? The 2-year impact factor is in 2018 it was 1.96, and then in 2019 it is 2.014. In 2020 we doubled it to 4.147. And as I was just talking before the giving an update before the talk, we are hoping that that number is going to significantly increase for us in 2021. And those numbers, again, due to some issues with downloading the data, JCI folks were not able to run the analysis for us in a timely manner, but we're expecting to see that within the next couple of months, for the 2021 impact factor. So we are listed as one of those top empirically focused journals. I'm not sure why they categorized us as being empirically focused. As I said, we are methodology blind, and we entertain papers across a variety of methods. And I was telling Devijit before the talk that 50% of the papers that we publish are analytical in nature. But anyway, so the basket of those 8 journals and the SCM list, basically a lot of schools, top schools included, have endorsed the list. And we are a part of that empirically focused journals with JBL, Journal of Operations Management, and Journal of Supply Chain Management. And the analytically focused journals are MSOM, Management Science, Operations Research, and POM. Yeah. Submissions. Last year, we received about 455 submissions. Acceptance rate is about 6.4%. And as I said, 6 issues per year with a total of 36 papers. And what are the topics that we're really focusing on? Again, we are not wedded to any particular topic, but we have 2 ongoing special issues right now. One is designing supply chain strategies for epidemic outbreaks, and Suresh Sethi from UT Dallas is one of the special issue editors for that. And the second one is behavior pricing and platform economies. That's the interface with information systems and marketing. So we've got some marketing scholars well known. And from IS, we got Subodha Kumar, who's the deputy editor for POMJ. And the newest one that we have is it just went through. It is in AI and decision making. So Mung Lee from University of Houston and the dean at University of Houston, Pablo, are the special issue editors for that. So that's the due date for that is January 2023, I believe. In addition to that, we've also pursued some invited papers from well-known scholars, like, for example, Sunil Chopra wrote a piece for us very recently. And again, part of these are the special issues, and these invited papers will also help us with the citations, and that's something that is important for the journal. So, so we've been trying to do that. But special issues, it has been tough for us to kind of manage them, because usually when you have a special issue, you've got a lot of submissions that come in, and our ERB is basically the volume significantly goes up in terms of the reviews that they have to perform. So we are restricting it to one special issue per year, given that it's kind of hard for us to manage the volume that comes with this by floating a special issue. People always ask me, is it getting harder to publish in DSJ? The acceptance rate is down from 12% when we took over the journal to 6.4%. Again, that's because so many levels that we have, and the paper has to go through all these levels, and at any level, the paper can get rejected, right? So there's a DE, there's an AE, and we've got this new ERB, and clearly the rigor of the reviews has gone up, and that all-important link to practice requiring authors to motivate the work with those direct interactions, that created some problems, and so that's another bar to cross now for the authors. So all in all, we are trying to make it a lot more rigorous, and again, minimize the probability of making a, what do you call, the type 2 error, okay, which is accept when you have to reject. So because you just don't want a paper to go out there and people may wonder, how did this go through the review process and get, accepted to the journal. So we are very careful about that, because that kind of has a a negative, it can send a negative signal out there, especially when you're trying to improve the quality of the journal and make sure that it's one of the mainstream journals for operations management. We need to be cognizant of the fact that we have to make these decisions in a careful manner. Okay, so all of that has brought the acceptance level, cut it down by half, really. So I think those are some of the things. In terms of the lists, again, as I said, there are a lot of political issues there. So we'll see what happens with FT50. We made a huge push saying that within the current FT50 list, at least, there are not very many interdisciplinary journals. So there's certainly a gap there. So we made the case that DSJ would be able to fill that gap. And again, we submitted all of that information last summer, and we've really not heard back anything yet. It almost seems like a black box, and we just don't know when the when the revised list is going to come out. What I heard was that it may increase from FT50 to FT60 or something like that. So we are hopeful, okay, that if something like that happens, and given the emphasis that a lot of deans at business schools are placing on interdisciplinary work, and so we'll see. Okay, we are optimistic, but we just don't know, given the given all the other constraints that are put into that process, and the political issues that go with it. So we are happy that we are on the SCM list, as I said. In terms of the ABS, which is the European list, we are ranked, I think, one below, like JOAM or POMJ. I think they're all ranked at 4. So we are ranked 3. So I've been in Europe quite a bit in promoting the journal. Part of the issue is that, I think in some parts of Europe, the journal is not very well known. So we are making a significant efforts, to go to some of the conferences there, the International DSI, or the EDSI, and the Roma, and so on, to kind of bolster the journal at those conferences. And the ADBC list, which is the Australian Dean's list, so we are ranked as a top journal there, I think A-star journal. So we are certainly happy about that. So yeah, I mean, that provides you with a little bit of introduction. The rest of it is, I think, for junior scholars and, in terms of some, advice and so on. But I'll stop there and
Yes.
open it up for new questions. Yeah.
This is very helpful. Thank you, Sri, to do it on a short notice. I think if students, especially doctoral students, would find that very insightful, I'm sure.
No, that's great.
Yes, I think very helpful. Thank you. And I think we went way beyond our time, but it was all useful conversation and very helpful. So if you, if you can send us the working paper, we'll also circulate to our participants. And hopefully next time when you're here, we can meet you in person, host you in person. That's important. Definitely.
Yeah. Thank you. Thank you so much for having me. It's certainly a pleasure. And please submit your best work to DSJ. I know that we do get a lot of submissions from India and also from China, but we're always looking for top schools to submit papers to DSJ. So yeah, I mean, we certainly want to make it a global journal. I think one of the issues is that it's very well known in the US and some parts in Europe and some schools in maybe India and China, but it's important to kind of especially if you want to be ranked in the FT50 and so on. I think now the ranking is based on the feedback that you get from scholars all over the world, okay, and not just from any part of the world. So yeah, so certainly. All right, great. Thank you.
Thank you so much. Thank you.
Yeah. Take care. Bye now.
Bye.